Okay, come back. Let me first load the chat. Okay, now I have the chat. I can try to set up the music. Nope, I don't have. Okay, I wish I could. Hi, welcome. Welcome back, Puncher Blue. Conhazis. I can just, if you're in the chat, you just let me know, because I want to open up the music. But I don't know what should be the volume. Let's see, I don't hear anything right now. Yeah, it's not playing right now. So let me open it. Okay, now there should be some music. I don't know how much is it loud enough, or is my voice louder? Is it good? Please make it 30%. So right now it's 90%. I can try to make it like this. That should be okay, I guess. Yeah, it was 90% for on the website, of course. But I think now it should be okay. Now it's like 30%. Maybe a little bit more, 35 to 40. Nevertheless, it's much more vibrant now. Okay, thank you. So let me make it. Okay. should be better now, I guess. Okay, very good. Can go back to the code. Okay. So the first thing that I want to do is, okay, here, load data. This name is bothering me. Okay, and for branch, I can just make it, wait, and then here, AABB, this is the right. Or I can just make this t.platform. This should work, no? Okay. Not that data, also destroy data. Very good. That should be our tree node, and then let's go back here. I have a root, and then there's allocator. For roots, I will put it as null null. Okay. And this is just the tree node that cannot be null anymore. I have to always set this tree node. And we're set to go. I think it's okay now. Yeah, here we destroy this EVH and we use the allocator to go to tree node and use the init function. Oh, actually I have to put okay, so make it nullable, I guess. allocator create. Okay. We don't have to do this. We just do it like this, I think. No. Am I right? No, I think I have to put it like this. Yeah, right. I have to put a question mark. And then say that, okay. It can be, yeah, I think this is true, but we will see. It's either this or I have to remove the question mark. So then here, now the insert. I don't want to use the recursive function. I will instead use a loop. No, I think a loop would be easier. So here, first I would put the parent. And this is a variable, I think. And then there is the center. Okay, the new platform and center. This is the center new, I guess. Okay. Is it horizontal? Okay, now instead of that, I can just use the. Yeah, okay. Parent dot. Oops, okay. So now while parent node just parent node should work, right? I'm not sure if this is gonna work. I think I have to put 4 here now. Yeah, this syntax, I'm not sure if it's gonna work. Let me check somewhere. Traverse data structure like linked list and API. So it's correct this time. And then what we do is this is to be horizontal, and then there is, okay, if it is horizontal, we have to check. We need to get a AAPB collision, by the way. Why? Because I have to see, so for example, I'm adding a platform and it's a rectangle. I have to see if this rectangle is contained in this thing. That should be the condition, not is horizontal, right? No, is horizontal is important to do division. Like for now, I'm gonna do division by half. So is horizontal is important for that. And I can make it just constants. But then I need AAPB collision. AAPB collision is, I will have rect1, which is, yeah, there are two rectangles. I will have the minimum, so that's like size. Okay, no, this is not what I want. I will do const min 1 is rect1 dot pose, and the max one is the plus size. Min 2 is the position, max 2 is the size. Okay. Assuming that the size is always positive, of course. Assumes that size rect is positive. There is max 1, 0, less than min 2, 0. And then if max 1, 1 is less than min 2, 1. Okay, very good, this works. Okay, this is gonna give a collision of each one of them. Now if there is a platform that exists in both of them, that would be a bit difficult to decide. Or we could just do with the center, no? Yeah, let's do with center. Okay, we will see where the center exists in this thing. Okay, so we have the horizontal. Now we have to check on so we have to divide the size to 2 by 2 to get const ranking, I guess, is current node dot AABB position plus size divided by 2. Okay, so we have the position and then divide the size by 2, and then we get the separation place, separation location. Okay. And index is equal to 0, else 1, and I will put if some condition where the condition is this thing. Okay. Oh, this is good. Okay, so now I have the index for my separation. Separating index is just 1 minus x. And okay, very good. Here next. Why do I want this non-separation? I don't know. Okay, so I had this separation index and then the location. Oh yeah, I want it because no, I don't know why I want it. Okay. Oh yeah, okay, sorry. Now what I want is top right, top or right is basically if not that the position or size. Okay, if center of separation index, it is top or right if the center of separation index is more than or equal to separation location separation index. Otherwise, this is bottom left. Then what we do is to have one condition. If it's top right, else, or just do a return here, or no, I have to do else because, or I can do continue. No. And then I guess that's more. Let's do else. Okay. What do I need to do is to have if it's that there is a top right child, if parents not the top right child location the child top on. Else create node, parent node, child top on. Create the node here, and then there's put a rectangle there. But then there is the data. I have to only do it if there is no data there. The data is no. If the data is not null, we continue. If the data is null, so first here I have to see if here stop right. Node, parent node. The parent node. The data. Okay, here we have to insert into one. Okay, if it's data, I have to insert that data. Why am I doing this? Because the branches shouldn't have any data, so if there is a data and I'm adding something to the same tree node, I have to move the data to a smaller child, like to one of the child, to one of the children, and then insert the new I'm gonna continue everything, right? Yeah, okay. So here, if there is data, it means that this node is a leaf node, so it does not have children. Initiate one proper child with respect to the center of data. Then put the data as data of that child. Then continue. Checking what the new platform should be assigned to. Okay. Then we go do the separation stuff. Do we need the separation before this? Yes, because I think we need the separation information on when I'm deciding what to do with the data of the leaf node. But this is a little bit inefficient. I should first add the new node, right? I should first add the new node and then add this one as so I should first, this is not okay, so first add the new platform as the data of one of the children. Next, add the data here to either other child or as data of next node. First child, right? Okay, here I don't know how to proceed. Let me draw it on my paper. You have some data here. Okay, so we added as a data of one of the children, add the data here. Okay. Set the new platform to the new platform to the data here. And try to insert this new platform node to the child node. Just create it. Just create it. Okay. So what I'm thinking is that there will be some really a lot of empty space and empty nodes, like having just one child, because this has to do the division until it goes to a situation where platforms are completely like opposite to another, like one exists, one center of one exists in the left one, and center of the other one exists in the right one. And it could go really deep. I need to maybe I should change it. I should change it to somehow using another measure, like median. By the way, how do I calculate the median? I can do the median, but then I have to sort things, no? I really don't know how to find the median. Can use the tree structure like okay, to make it like using median, I should just compare the new platform with the data that I already have and see which one is the right or left of each other. For example, if I'm doing horizontal, then add the left one to the left child and the right one to the right child. Yeah, that's just it. And it fixes everything. I don't have to go really deep and insert stuff. And then if I find a child that is more left to this, to the left child, then what? Because if I use AABB, I would have to make things half, and then until I get a point where the AABB clearly includes one platform and the other one includes the other one. And it's really difficult, this thing, also because some platforms could be in the center point of when I'm doing division and stuff, and it becomes much more complicated and weird. Right? No, I'm just doing a center, so it's okay. Okay, I'm gonna ask AI some question. There's clearly some misunderstanding that I have. more paper. I will have some root. It has 2 children, TRTL, then ABB, and then there is data. Okay. And then we check first. So the root thing is now at the beginning. We create with the shape and 2 children which are now, and then we put the data to the platform as the first element. Okay. Okay. Else we do create a node. No, else if it's not, we check the center. Okay, let's try. This is the new platform, and then it's a notable tree node. Parent, then do something. No. Not gonna do while anymore. Let's first try the easy way, and then else. Okay, and create node. What does create node do? Insert rectangle. I'm not gonna use this. Gets a node and then some platform. Then it creates some node. It shouldn't, honestly. The only thing it needs to do is oh no, it was null. Now we should create this kind of a thing, pointer in node, and inside of it we need to put this null and the data equal to that. And this is that data. Okay. Let's see. Now, if this thing exists, first we need to know if both children are not null and null. So if child bottom left, right, bottom left. Okay. If top right. Top right. Okay. Else. Okay. I guess I have to go through all of them. So here is when both of them are defined. If both are not defined, just do top right platform. If both of them are defined, insert and now here, okay, one of them should be chosen as the one. To do that, we have to do this calculation, separation, location, index. No, we don't need this. Do we? We need it, but the condition must change, right? Because check here if both children are okay, then we first check separation location. It was the difference. With the BL, the AABB position, AABB center Define the difference between their center, the separation. Okay, distance. And then we do the index would be if the new center, the new platform center, okay. Now, if the new center this is just if the separation index, it's not the center, it's just so this is a difference, right? This is a difference. It's not distance, this is not center. By the way, this is just a distance kind of thing. Distance. Distance. Okay. Now if this distance is bigger in x, then we're gonna do index 0, else 1. Very good. Non-separation index is 1 minus this. Okay, that's cool. Now I just want to do okay, now we have the separation index top. If the center, if the new center, by the way, this distance could be negative, so I'm gonna put F's, right? I mean, I'm expecting it to be non-negative, right? New center separation index is now this should give us center, right? Okay. Then if is top right, okay. Here I have to enter child tr and platform. Yep. Okay, very good. Okay, now if tr is not defined, then create a node child tr platform. If we assign it to top right, it could be the bottom or left of the other child. How do we know that now? So we need to do the same thing. We need to calculate the distance now between the new node and bottom left one. And first see what is the distance, and then decide this separation index there. And then within that separation index, see which center is higher or lower. And then from then we can decide okay, we can create some node. Okay, care about the center anymore. Not anymore. I just care about the separation index. There's the distance, and then here is the top right not defined, right? Okay. We here instead of top right, I have to put the new center. We calculate separation index, non-separation index from that. And then we'll see if it's top right. How we can check if the new center is bigger than or less bigger than or equal to, there is no center, there is center. Okay, if the center is bigger than the other one, separation index. Why do I calculate non-separation index? I don't know, I don't need it. If it's top right, we have to do some stuff here. Else, here we have to do something else. If it's supposed to be top right, then just put it in top right, right? If it's not supposed to be top right, then that file top right must be current node. Okay. Okay, this is cool. Now if it's not bottom left, we have to do similar stuff here. But with this difference that here we do top right center, top right, new center, top right center. The separation index, this is top right center, this is the new center. Now, if it's top right, this difference that this is BL, TR, yeah, oh, this is BL, okay. Honestly, I don't know if there was a way to make this more simplified, but this should work now. The only way we continue the search to find the insertion place is if both of the children are null. In that case, we just do calculation. Now we have to update AABB after insertion. Okay, these are not useful. This is the function, right? Okay. How do we update AABB? We just put the, okay, so I guess we put the minimum for AA and maximum for, we calculate the minimum and the maximum between the minimum between the positions and maximum between the positions plus size. And when we do that, we just calculate the maximum and minimum corners, locations, and just we update the whole AABB there. Right. Okay. How do we do that? Expand AABB. And and then we'll give it 2 rectangles. Right. 2 feet with length. Const, city that map that minimum. I think there was minimum position 0, position 1, max x and max y, and then you have to return. Yeah. Okay. Get x and the AAP. Okay, so here in any case, I think we just have to extend it with the parent node, right? Yeah, if the parent node exists, we have to just update it with the parent node. Parent node the AABB is just get extended BB. This is shape. Yeah, okay. And then for this, so shape could be I will change the name of the shape for platform to AABB. layer, I'm gonna not change it because okay, here, hey, layer we don't care, layer we don't care, platform it could be AAB. Okay, now types, map area, let's DVH, it's a DVH. Yeah, I'm gonna call it undefined. And then here in my setup, I'm gonna be okay. Init. Do I have allocator in my map? No. I'm gonna put allocator. And then maybe I'm not gonna change everything. Let's first try if this thing works. To do that, we will have some platforms. I'm gonna just do a loop over map.plats, plats. I'm gonna insert them to my DVH. And then to see if this is working, I need to go through all of them and make a print, right? Okay, there should be BVH. I'm gonna do print. Here is BVH 3. Any okay, let's try. There is clearly some error here. Where is the error, by the way? It says error, but I don't find any. Local variable constant. Where? class that I have created and I have not used. Do you also hear there is some weird noise in the music, or is it me? I guess it was me only. That was a long... Okay, use of undeclared identifier EVH. Here, const h import .sig. Okay. Print. Alright, no field or member function name setup. Oh yeah, of course I made a mess here. Okay, so oh, by the way, I don't have to initialize here. There is no need for any map shape in the init function. Yeah, the map shape could be okay, we don't need that. It's null from the beginning, so member function expected 2 arguments found 1. There is insert, there's the parent node. Okay, there should be a way to fix this. So I'm gonna make a public function, insert bvh edge and some platform, take that platform, right, and then I'm gonna use bvh dot insert node bvh root. Okay. Okay, this should be better. No. So I don't have to call use bvh.root from outside of the function. Platform from type.direct. Where? Oh yeah, okay. Mixed scalar, oh yeah, okay. So rect that size. It's here, no? No, it's types Z20. I think I did the similar stuff there, no? I did some division by scalar. Yeah, I did a lot of division by scalar here. Okay. Our union is ignored. Oh, vector is not. const vector t dot vector. Member function expected like one argument from 3. Insert inside notes, by the way. And this is try. Okay. What else? Create node. 2 arguments found 3. Oh yeah, okay, I see. Okay, cannot assign to constant. Node is a constant. Where is node 79? Okay. I have to give a reference pointer to an... This is weird. Okay, so what am I doing here? So I have to do a reference, right? So if I'm creating a node, I have to send So I'm sending optional pointer there, which is null. have to do, this is a weird thing, so this should be a pointer, and then I have to do this, right? No, I have to do this, and then this. Something like this. This is crazy. I mean, it looks funny though. Star, question mark, star. And then when I'm using create node, I have to put an ampersand. Let's see if this works. Data equal to platform, by the way. Data is a nullable thing. It shouldn't be a pointer, by the way. It just should be a nullable thing. It should be optional data. Right? Where is... This should be optional, right? Okay, it's here, and then yeah, that's it. Okay, but this one is a bit more complicated than I could understand right now. So this is a constant pointer to a changeable data, right? To a constant null. Okay. Right? No, I think cannot assign to a constant. Clearly I'm tired. I don't remember how to do this. Let me update. Working BBH. So I'm going to end the stream now. Thank you all for watching. It was a good stream. I worked a lot, and hopefully I will be able to continue and finish this. Thank you all for watching, and don't forget to subscribe and like the video if you haven't done already. Have a really good day or night wherever you are. Take care. Stay healthy. See you. Bye bye.